Good morning.
Good morning.
Aww. Or for those of you watching this on film, good evening, afternoon, night, whenever you're watching this. This time is an extension of last week's series, and it's part of these 5 lectures are designed to give you an introduction. And the middle 3 are kind of linked together. So my hope today is that we finish going through the design process and talk about the later phases and some ways to approach your design. And want you to see this, to be able to situate where your project is, where it's gone, and hope to understand where it's been, and to give you some tools to be successful. Some things outside in the EPICS lab, some of the things that are going to be coming up, there's an individual evaluation rubric. So grading in EPICS is kind of like a performance appraisal out in industry. What we try to do with a lot of the things in EPICS is get you ready, transition you from being a student and start thinking as a professional. You will get graded your entire life. Those of you on film, the students here do not look excited. But you don't get grades, right? When you work for a company, you don't get letter grades. What do you get? Yeah, raises, promotions, or if you don't do so well, yeah, layoffs, fired, whatever, company goes bankrupt. But you get performance appraisals. So one of the things we want you to start to learn is how can you set goals and then articulate your progress towards those goals. So the goals are the semester plans. Now, I know some of the teams, when you look at the semester plans, you treat it like an assignment. But what it's meant to be is that's kind of the grading scale. You know, in a math class, you come in and go, okay, here's the sections that you're going to cover. Or in an English class, you're like, here's the papers you're going to have to write, here's the books you're going to have to read. In EPICS, you get to help decide how hard the semester is going to be. Isn't that cool? And it doesn't mean it's like, oh, we want to make it as easy as we can. It's negotiated with your advisor. So semester plan is supposed to be that discussion about how much your team's going to get done. And then within that, you should be able to see how much you're going to get done. So in week 4, which is this week, the semester plans are supposed to be finished. And your TAs may be doing a check on, hey, let's just see what your goals are. Take a look at the evaluation rubric to say, what am I going to have to do at mid-semester to explain my progress? And they may take a peek at your notebooks, your documentation. Because one of the things that's important in EPICS is it's not just what you've done, it's how you've documented it. And I like to think about it as an exam. When you take a traditional exam, you're demonstrating your knowledge of the topic, right? So if you turned an exam paper in, if you're talking to the professor and you talk with the professor and they know, during office hours, and they know you know the material because you're talking and they're quizzing you and you can answer everything. You get to the exam, you sign your name, you know the professor knows you know everything, and you turn it in with the rest of the exam blank. What would your score be? 0. So if you don't document what you're doing, we have to follow the same process as any other course. Does that make sense? So the documentation is providing evidence. The other thing that a lot of you have already seen is the documentation on the design is what carries over for next semester. A lot of you have read the documentation from previous semesters. Any of you see some ways that could have been improved and been better? Yeah, okay. Remember that because that's what you want to leave for the next semester, okay? And that becomes that, all right? The other thing is it's really important the websites get updated with that because we have 14 companies that provide funding. We have 35 other universities. Your websites get looked at by people all over the world. And that's an important thing. All right, the design process. Now, one of the weird things with the lecture part is you don't get graded on this part. It's kind of like you showed up with attendance. But to get the most out of, so week 1 we talked about in EPICS, you're going to get out of what you put in. So there's the design document that explains our design process. Those are the things you're going to be evaluated on during the semester. So reading that to give tools is going to be very helpful. It's the only assigned reading. It's up on the website. We showed you where it was last time. How many of you are through the specification phase on your projects? Past that, okay? How many of you think you're going to deliver your project this semester? Cool. All right, we're going to talk a little bit about that. Any comments on when you went back and thought about the specifications, project identification? Thoughts, comments, ideas? I know, I just asked a 7:30 section to respond and to wake up. I will warn you, design reviews are in week 7, 3 weeks away. Wow, 3 weeks away. There will be design reviewers that will ask, where's your specifications? It is important to present the specifications, requirements for your project in the materials that the design reviewers get. The industry people are used to seeing these so they can understand where you're headed. If your team does not have one of those, work to get one together. It's a great way to really understand where you're headed. If you don't have a set of requirements, you do not, especially those of you getting delivered, you don't know when you're really done unless you've got those requirements that are going to be met. Okay? All right. We're going to go through, so we talked about the first 2 phases. We're going to go through the specifications or the conceptual design, all the way through the detailed design a little bit, highlighting some tools. There's more details in the design process document. I'm going to assume at this point, when we get to conceptual design, we've got 3 things. We've identified a problem that we think is really valid. We've got somebody who's going to use it. Every project in EPICS is intended to be delivered. So if for some reason your project partner vanished or whatever and the team's working on a project that's not going to get delivered, that project needs to be terminated and a new project needs to come up. But we've got a valid project. We've got a list of requirements. And we've explored existing solutions, and there aren't any that really meet the requirements, so our work is needed. The reality of the other thing, so in theory, at this point, we are not tainted. We have only thought of requirements. We do not have any ideas in our head. And I've been doing this long enough to know that's just not reality. Because as we've gone through, immediately when we got the project, in our heads, we developed an idea. And it's a precious idea because it's ours, right? Now, a lot of you, and I talked about this last week, might have used like, oh, here's my prototype. And I've mocked this up because this is my idea and it's really precious and it's really cool because it's mine. But what I did is I used it. I used it to go back for the requirements. You know, I gave it to my partner and said, is this about the right size? What do you think? Maybe. You know, a little heavy. Okay, what would you do with it? Last week, I think I talked about when we tried to deliver something to a school and they couldn't store it, right? So, you know, what are you going to do with this? If the person picks it up with their left hand, I'm like, You know, as we worked with it, we said, oh, what about, you know, can I get to this? I'm a mechanical engineer, and we at Purdue sent a lot of engineers to the auto companies. When I go to work on my car and I can't get to something, I get terrified. I get terrified that it might have been one of our students was the design engineer that didn't think about how somebody was actually going to do maintenance on this. Okay? I don't want you to be those kinds of designers. I want to think about it. Okay, so the reality is we have ideas, and that's fine. What we're going to do with the conceptual design is talk about how we can take that idea and expand them to get the best idea. And here's the issue. So I'm here as a designer, and I've been thinking about this, and I have my idea. Isn't this cool graphics? This is the most I can do on power. Okay, I kind of like this. The problem is, here's my idea. Now, I want to train you all to be most effective for your partner. I also want you to be very successful in your careers. And the problem today is there might be another design team somewhere in the world that comes up with a better idea. The challenge is, here's the ideas I'm exploring, and my idea is the best of the ones that are on our list right now. But there's actually a better idea. If you're a company in the market, when somebody comes out with a better idea, they put you out of business. So the key in the designer is, how do I create a design, they call it a design space, or a list of ideas where that better idea is there. Because once I have that better idea in there, and if I have a systematic process for evaluating the ideas, I'm going to realize, okay, this is a better idea. I'm going to have to go through the grieving process that my idea isn't the one we're actually going to make. But when I think about it, I'd rather keep my job, right? Or in this case, you want the partner. Now, I will tell you more often than not, if you came up with something, I'm also going to show you that it might not be one idea or the other. There might be aspects of my idea that end up in the final design. So I can claim victory in some point. But that's what we want to do. So one of the ways that you do this is we can sit around and we can brainstorm, but there are some tools to do this. And one of the ways is called a functional decomposition. Now, functional decomposition, what we're doing is trying to figure out what our project needs to do, not how. Immediately our brains go to how, but if we say, okay, what are the things that it needs to do? And the idea of this is you start with the function of your project and then start to break it up into sub-functions. And what I'm going to do is I'm going to think about what are the best ways to accomplish the different things it has to do. Remember, we had the requirements. So if I think about this to say, okay, what are the ways to do this part? What are the ways to do this part? And an example here, okay, so in here, each sub-function is going to be represented with a box. And it's going to have an action verb, and then the object on which the verb acts, maybe a modifier. And the idea is that what flows through, materials, energy, control, information, and we're going to focus on what it does, not how. But what I want to do before we brainstorm is what is it that this has to do. So if I look at something like a coffee maker, right, which for 7:30 class might be very important. Never got into coffee. Ugh, love the smell, love coffee, ice cream. Ugh, I don't know. But anyway, so if I think a coffee maker, it's like, okay, I got to store and heat water. Is that one function? Is that one function? It's two, isn't it? I got to store it and I got to heat it. Are those different things? Yeah, so when I start to break this down, I could actually break this down. How could I store the water? How could I heat it? Store and grind the coffee. So I'm starting to do this. Okay, I got to store and heat the water. I got to store and grind the coffee, brew the coffee, keep the coffee warm. I can go through and I can break this up and I can store the water. I got to heat the water. Now, another function, if I'm doing this, I might say I may have to pass the water from the storage to the heater, right? One of the other things when I look at it, you think about like a mechanical pencil. one of the functions of it is I have to store the lead and I have to actually get it to the writing position. How many different ways are there to advance the lead? They're the ones that on the end you click. I can side click it, some I can twist. So there are different ways. The idea here is now I'm going to say, okay, what are ways? Let's brainstorm ways to store the water. Let's brainstorm ways to heat the water. I can go back to my area. I'm like, ooh, my idea here was a great idea to store the water. And here's the piece. So the intent is I'm going to break this up and we're going to start to brainstorm on ways to do the different parts. And now we're going to pick the best aspects of each function. Does that make sense? This is a way that industry actually uses, and then I want to reassemble this part. This is an example of an actual EPICS project where they had card identification, a board to interact, communication device that had individual cards that spoke. So if you look at, they broke it up into functions and then sub-functions. It's like, okay, I had to identify a card, identify specific cards, identify when the card was in and placed. And now I can go through and I can brainstorm those different things. And the idea is then we brainstorm those and then we start to look at what are the best ideas within each category. Now when you do this, you've also got to go, okay, if this is the best idea here and the best idea, are they compatible? Okay? What it also does is it doesn't go, I got an idea and you got an idea and we're going to fight over whose idea is better. It's like, hey, what aspects of your idea is going to make this design best? And it's a way to bring this out. All right. This is what I was saying. Now, when you're brainstorming, there are a lot of, how many of you have ever been in a brainstorming session, some type? I should say, how many of you are awake? I probably would have got the same number of hands. So when I'm brainstorming, some things you want to do is you want to get lots of ideas out. One of the critical parts in brainstorming, and there are a lot of jobs that I think would be really cool. And one of them is a management consultant. And some of these management consultants will go through and like you'll have whole day sessions on brainstorming. They're kind of fun, you know, it's being creative, letting go. And in those, from the research on this, a fascinating thing I find is when people study like the most brilliant ideas in these brainstorming sessions, they almost always follow a stupid idea or stupid ideas. Now, stupid is judgment. Maybe an idea that was not realistic. Maybe that's a less judgmental way. Kind of something way out in left field. And from the way this has been described to me is we tend to be in our little boxes looking at an idea. And it's interesting now that they can do brain scans and stuff so they can actually see. We use a very small part of our brain. But in brainstorming, when somebody gives an idea that's way out left field, not related at all to the things you were thinking about, it physiologically activates a different part of our brain. And we're like, okay, so we have to actually acknowledge it. Because one of the things in brainstorming is we're creating a list. So somebody said the idea, inputs that, and then they wrote it down, so I'm processing that, activates a different part of my brain that was irrelevant to the task at hand, because clearly I was thinking the right way. But now your brain has to get back to reality. And as it does that, it actually activates other neurons in your brain to get back. You ever have an experience where you walk out of an exam, like there's a question you couldn't remember, and then later you're doing something totally unrelated, and you go, oh, now I remember it. Okay, it used to happen to me all the time. Some of you must be better at remembering everything than me. But what that is you couldn't find where that memory was. and you were doing something else, and as your brain is doing something else, it happened to activate those nerve cells, and it said, oh, we found it. And that's what it does. So the ideas of getting wild ideas out there, what it does is it serves to activate more of your brain. And you can do that in a different way. One of the tools in brainstorming is this acronym SCAMPER. So you use SCAMPER as things to say, okay, I'm running out of ideas, to say, okay, well, maybe we can substitute something, or we can combine ideas, or we can adapt something. Can you modify, minify, magnify? Can you change the current idea? Make it smaller, bigger? What if it was microscopic? What if it was huge? Put to other uses, eliminate something, reverse, rearrange. Another tool that I've seen in brainstorming a lot is you ask questions like, how would nature do this? You know, you're designing a vehicle. Have you ever seen an animal with a wheel? It's interesting because they were trying to design more effective vehicles to do search and rescue in natural disasters. And it's like how you build, essentially you need a tank to go over the terrain. And they were doing one of these brainstorming sessions, they're like, let's think about nature. I'm like, you've got all these creatures, like insects can climb over whatever. So what they started to do is design the robots without wheels, but they look like insects and they could crawl over things and get to places. So sometimes those things would work. In each phase of the design process, there's times where you get ideas out and then we have to narrow them. So this idea on the functional decomposition and the brainstorming is now we're getting all these ideas out. Now what I need to do is I need to narrow them down because we want a choice. And one of the ways to do this is a simple little table. We call it a decision matrix. And the idea of a decision matrix is a table where we list alternatives, and then we're going to evaluate them. What we're trying to do is to get into, I've already picked on you. We've got ideas up there. We got 3 ideas, and one's yours, one's mine. So obviously, I think mine's the best. And you're going to think yours is the best, and you're going to think yours is the best, and you don't look as excited about your idea. Okay, and so we're going to advocate, like, no, this is why it's so brilliant. So we don't want a subjective thing about, like picking a design. It's like, why'd you pick that? It's like, well, she debated best. What you want to do is you want to have the design that is objectively the best. So what criteria would we use to evaluate this? What have we already created earlier in the design? The specifications, our requirements, right? So which of these meets our requirements most effectively? Now, if I'm breaking this up by components, all the requirements may not fit every function. Which ones are valid? We put those into a table. So generally, you list the alternatives as the rows. Okay, and then you're going to have a criteria for comparison. You're going to weight them, and you're going to develop a score, kind of like this. So this is a little example. And instead of little decision matrix, and you can use decision matrices for all kinds of things in life. Like, I've got multiple options for a date Friday. Let's do a decision matrix. If you do that, just don't tell anybody, because then they're like, nerd, geek, whatever. But unless you want to embrace that. But here are the different criteria. All right? And then here are my choices. Here the choices are columns, sorry. Okay? And I've got 3 different, so these could be my ideas out of my functional decomposition. And then here are the criteria. Now the weights, what we put in, are how important something is. Now, one thing I want to tell you about a decision matrix, it's a powerful tool, wonderful tool. I think it should be used anytime your team needs to make a decision for a couple reasons. One, it gives you a way to quickly quantify something. 2, you can present this at a design review to share with somebody else why you made those decisions. And that's one of the things the designer reviews are for, not to grade them, but if somebody says, hey, wait a minute, when you pick this alternative, shouldn't you have considered, one of these criteria more heavily? Or did you think about this kind of option? It gives them a way to provide input. Third thing, remember what I said is you had to document your progress? This makes a great piece of evidence of your work. Here were the alternatives. Look, we investigated all these different alternatives and we used a solid process. Wonderful. Fourth reason, you're trying to go back this semester and figure out why did the last team make the decision they did. This is part of the documentation so future teams can say, this is why they made that decision, and not have to go back and reinvent something. So when you do this, it's a way to quantify. I will caution you though, it's not a precision instrument. Partially because there are subjective parts, like how much are you going to weigh one criteria over the other? There's not a mathematic formula for that. So when you do these, you still want to use your brains. And to go back and say, we've quantified this, let's take a step back and see if the result actually makes sense to us. As a designer, you always want to make common sense. So if I do this, I come back, and here's an example. Like I do this, and I've got company A is 70, this is 68. Do I just automatically go with 70? Now what it did is to say, okay, these two are higher than these two. Let's just go back and let's just talk through these as a team to make sure that one makes sense. The other piece, and we mentioned how it's iterative, a lot of times you'll go through and go, okay, option A is what we're going to go with. At some point you get in and like, you know what, this isn't going to work. So what you do is you go back to the decision matrix and said, you know what, we had another option that was really quick. We don't have to go through the same process. Let's grab that and produce that. Does that make sense? So you do a decision matrix, you go back, you show that. You've got your concept. Obviously, when you're going to do this, you're going to mock it up. And you're going to show it to the project partner as part of the criteria for that. Then, once you've got the concept, what you want to do is you want to implement it. You want to put it into place. And this is in the design phase, or the detailed design phase. And what this is we've got our idea, now we have to figure out actually how to make it work for our user. And one of the things at this point you want to look at is failure modes. How could our idea fail, and what would be the effect? And the idea here is you brainstorm failures. What could go wrong? And then what we're going to do is we're going to rank them under 3 different categories. Severity. What would happen if this failed? 10 being somebody's going to get hurt or killed, or very bad. 1, inconvenienced maybe. And you want to lay out your scale. The occurrence. How often is it going to happen? 10, frequently. 1, hardly ever. Now the final one, detection's a little different. A 10 means it's hard to detect. A 1 means it's very easy to detect. Does that make sense? So a dangerous failure is one you don't know happening. And I'll use an example. If you're driving a car, every car has brakes, right? Right? Those of you mechanical engineers better go, yeah! Okay? What % of brakes eventually fail? Wear out. All of them. Occurrence. Every single one of them. What's the severity if brakes fail in an automobile? What would you rank that as? What? 10. You can't stop the car, you could die.